So today we are going to study about relative motion. Okay, so we have studied about what will be the motion in 2 dimension, what is projectile motion, right? How to solve some problems on projectile motion, then equation of motions and how to use vectors. Okay, so we have studied about those things. So today we are going to study the next topic, which is relative motion. So I hope all of you have gone through the book that I have sent you. Message to host Janvi. Morning everyone. Okay, so message to host. Okay, right everyone. Okay, so I hope everyone have gone through the book. I've already sent the book in the Google Classroom. Yes? Okay, very good. So in that book, everything is given in detail, right? So you don't have to make any notes. Okay. You should refer motion in 1D first, then motion in 2D. Okay, right? There's a chapter motion in plane, right? Okay, motion in plane is your motion in 2D, right? Okay, so this chapter, this topic, relative motion, okay, it is kind of mixed of motion 1D and motion in 2D. But before that, let's think about a simple problem, just simple problem, because we have already discussed the frame of reference, right? Tell me, what is frame of reference? Aware, tell me what is frame of reference? I've unmuted you. Okay, Aware, do you know what is frame of reference? A point of observation? Anyone? Yeah, Janvi, can you say what is frame of reference? You guys are unmuted. You can speak. Anyone? Mansa?
Sir, origin.
It's not always origin. Okay, it might not be origin, right? Because origin is a point. Okay, origin is a point, and frame of reference may or may not be a point, right? So basically you can say that frame of reference is your point of observation. Okay, point of observation. For example, I gave you example of a person sitting on a fan, right everyone? A person sitting on a fan. Now suppose you are sitting on a fan, right? Then according to you, fan is moving or not? Tell me, according to you, fan is moving or not? No, right? Fan is not moving. Okay, so according to you, if you are sitting on fan is stationary. Yes or no? Right? So I can say that if two friends, suppose, right? Avya and Prahlad is sitting on the fan. Suppose, right? So according to Prahlad, Avya is in rest, and according to Avya, Prahlad is in rest. Yes or no? Agree, everyone? Tell me, everyone agree with this? Okay, very good. So I can say that according to Avya, Prahlad will be in rest, right? And according to Prahlad, Avya will also be in rest. Okay, when they are both sitting on fan. Okay, they are both sitting on fan. But suppose if Avya is sitting on fan, and Prahlad is sitting on the chair below the fan. Okay, on the chair below the fan, right? Below fan. Now tell me, according to Avya, right, what will be the motion of Prahlad? Tell me, according to Avya, what will be the motion of Prahlad? Because fan is moving, right? Fan is moving in circular motion, right? But what Avya will think? that Prahlad is moving, right? So according to aware, Prahlad will be moving in circular motion, right? And according to Prahlad, aware would be moving in circular motion. Got it, everyone? Right? So see how the point of observation changes the motion of an object, right, everyone? Got it? Right? Now, have you ever observed when you're sitting on a train? Okay, when you're sitting on a train or bus or car, if you observe the plants or anyone outside, you will see, yeah, it will seems like they are moving backward, right? How many of you observe this, that it seems like people are moving backward, right? They are actually moving, instead of us they are moving backward, right? Why is it so? Because we are in rest with respect to bus or train, okay, and the objects are in motion with respect to us, right? So obviously, since we are the point of observation, right? So I can say that the object which is outside will be in relative motion, right, everyone? Got it? So I hope all of you understood what is the meaning of relative, right? It's with respect to something, some reference point, some reference frame. Okay, everyone? So I hope all of you got this. What is the meaning of relative? Tell me, yes or no? Yes or no? Anyone have any issue in this? Anyone? Okay, so this is conceptual understanding. Let's talk about mathematical explanation, right? So let's see. Let's give the heading relative motion. It's very easy actually, right? People are confused, but if they have very sound understanding of this concept, questions would be easy. I hope all of you remember vectors. Tell me, all of you remember vectors? Yes or no? Is there anyone who doesn't remember vectors? I guess everyone remember vectors. Okay, so let's see. Suppose we have an velocity, right, of Prahlad, with respect to aware, right? Velocity of Prahlad with respect to aware. Okay, Mansa, my voice is not breaking. My voice is very fine. Okay, it might be your internet issues because I'm speaking as well, listening to myself. Okay, everyone, my voice is fine. Tell me. Yes, it's clear. Okay, Mansa, please check your internet assets. Okay, so see, this is velocity of Prahlad with respect to aware. This is how we have to write. Okay, velocity of man with respect to ground. It's written like this. Velocity of man with respect to river, right? So the first subscript, right, is your velocity of object. Second one with respect to what? Okay, right? So this is velocity of Prahlad with respect to aware plus velocity of aware with respect to ground, right? Okay, so suppose this is velocity of Prahlad with respect to aware. Okay, so this is magnitude wise, this is 10 kilometer per hour. Okay, 10 kilometer per hour with respect to aware. Now aware, it positive, right, in g direction, right, or I axis. Now velocity of aware with respect to ground is 5 kilometer per hour. Okay, this is also in I-axis, right, plus only. Okay, everyone, right? Now just think about this, just logically think about this. What will be the velocity of Prahlad with respect to aware? Tell me, what will be velocity of Prahlad with respect to aware? Think about this now, right? And what will be the velocity of Prahlad with respect to ground? Because with respect to where it is 10 km per hour, right? Given. Very good. What will be? Well, what will be velocity of Prahlad with respect to ground? Tell me. Yes, Prahlad? Very good. Think about this. Think about this. Satvik, it's wrong. Yes, Abhay, correct. Think about this. Yes, yes, Yashila, very good. So it will be velocity. See, this is how you write it. Velocity of P with respect to A plus velocity of A with respect to G will give you. So in middle, we have this A and A. So it will be eliminated. So we have to write velocity of P with respect to G, right? So this is the velocity of Prahlad with respect to ground. Okay, tell me everyone, got this? Yes or no? Right? So it will be 10 plus 10 plus 5. ठीक है? Okay, so let's see another problem. Let's see another problem. This is actually the statement. Okay, this is actually the statement. That's the only formula. It's not even formula, it's a concept of relative motion. 15 kilometer per hour, right? So this is like this. Velocity of object A with respect to B, velocity of object A with respect to B plus velocity of object B with respect to C, right? Velocity of object B with respect to C should be equal to velocity of A with respect to C, right? For example, I'm giving you one more example. I'm giving an example in motion in 1D to have a better understanding, right? So I can say that suppose, how many of you watch Bollywood movies, right? I hope all of you watch Bollywood movies, right? Yes. So we have seen in Bollywood movies, the actor heroes, they run on the train and they fight and all those things, right? That crazy fight scenes running on the train and then fighting. Okay, I hope there's a movie called Ravan of Shah Rukh Khan in which he was fighting on the train and all those things. Now just imagine. Okay, we have a train, right? We have a train, train. Okay, in that train, the Shah Rukh Khan, the actor, right, is running, at a speed of 10 kilo or meter per second, 10 meter per second. Just imagine, right? So this 10 meter per second is the speed of SRK with respect to this train. Yes or no? Tell me. Yes or no? Okay, right? So I'll just use vector. So velocity of Shahrukh with respect to train. Just think about this. Is equal to, this is your x-axis, right? This is your x-axis. So I'll write it as 10 I cap, right? Got it, everyone? Now where I just said that we have a Shah Rukh Khan. This is a train. Shah Rukh Khan is running on the train from the movie Ravan. Okay. And the speed is 10 meter per second. So this is your positive x-axis. So I've written 10 I cap. That's the information that I've given. Okay. Now, case one. Case one. Right? Just think about this. I've given you case. What will be the speed or velocity of Shah Rukh Khan with respect to ground, right? If if velocity of train, right? Or I'll just write like this. If train is moving, if train is moving in x-axis, right? Positive x-axis, right? With speed of 15 meter per second, right? This is case 1. Case 2, right? Find velocity of Shah Rukh Khan with respect to ground. If train is moving in negative x-axis, right? With velocity of 20 meter per second. Okay, tell me, right? Everyone, tell me. It's meter per second. It's meter per second. Where unit? Please mute everyone. Okay, got it everyone? Yes, very good. Very good everyone. Okay. So see what you did. It's very simple because it's in one dimension. Okay, right? Got it? Okay, so I can say that velocity of, just write like this, Shah Rukh Khan with respect to train plus velocity of train with respect to ground will give us velocity of Shah Rukh Khan with respect to ground. Yes or no? Right? Yes or no? Okay. Since it's in one motion, one dimension or two dimension or three dimension, doesn't matter. Right? This relationship holds true. Right, everyone? Right? Okay, let's see. Case 1. Case 1. Velocity of Shah Rukh Khan with respect to train is 10i plus velocity of train with respect to ground is 15 I. So this is a velocity of Shah Rukh Khan with respect to ground, which is equal to 25 I cap. Got it? It's simple, right? Very good. Now, case 2. Case 2. Case 2. Velocity, same velocity of Shah Rukh Khan with respect to train plus velocity of train with respect to ground is equal to velocity of Shah Rukh Khan with respect to ground. You should, sorry, respect to ground. You should be focused on these two, right? Plus and these two. Then you can just eliminate this. Okay, right? So it will be 10 I cap, 10 I cap minus 20 I cap, right? Is equal to velocity of SG, right? So this is equal to minus 10 I cap. Okay, got it? Right? We are coming to that now. We are coming to that. Okay, so this is the one dimension, but obviously since it's a vector, you can extend it to any dimension. So let's see one other problem, right? Let's see another problem. Question number 2, right? Suppose velocity of, I'll just write like this, right? Just think, suppose this is your river. Okay, this is your river, right? Now we have a boat over here. We have a boat over here, and someone is sitting in this boat. Okay, now the thing is this boat wants to go from this direction to this direction. Okay, just think about this, right? Just think about this. The boat, right? Now where ij is not unit, right? It's the direction. So I have not written the unit over here. The unit would be meter per second, obviously, right? The unit would be meter per second. I have not written the unit over here, right? Meter per second. Okay, so yeah, so the problem here is this boat, right, wants to go from this point A to this point B, right? It wants to cross this river, right? So let's suppose the velocity of boat. Okay, now with respect to river, right? With respect to river is, this is moving, this should move in x-axis. So let us take as 5 I cap meter per second. Yes or no? Tell me. Yes or no? Tell me. You got this, right? How come it is weight of boat with respect to river? Because it is going in this direction with respect to river only now. If a person is sitting in the boat, right, so obviously he will feel that he's going forward only. Yes or no? Tell me. Agree with this? If a person is sitting in a boat, right, in a boat, right, he will think that the boat is going in forward direction only, right? Okay, but what will happen since it's a river is flowing in this direction? Yes or no? River is also flowing in this direction. Yes, right everyone? Right everyone? Okay, so let's see velocity. Now, if river is flowing in this direction, right? So it is with respect to ground. Yes or no? Tell me. This river is flowing in this direction in y-axis with respect to ground. Yes or no? That you are imagining. Just try to imagine. Physics is all about imagination. Okay. So if you see the river, don't see the boat now, right? If you see the river, then river is flowing in either this upstream or downstream, doesn't matter, right? Here I'm saying it is flowing in this direction, right? Now this is with respect to what? This is the direction with respect to what? With respect to ground. Yes. So I can say that velocity of river with respect to ground. Now it is your negative y-axis. Yes or no? Now we have got it. This is your negative y-axis. Yes. So I will write it as minus. Suppose I have given 3 j cap meter per second. Got it, everyone? Tell me. Minus 3 j cap meter per second. Yes or no? Yes or no? Let's rewrite this or just redraw it as a vector. So I can say that this is the vector. This is the vector of velocity of boat with respect to river. Okay, and this is the vector. This is the vector of velocity of river with respect to ground, right? So what will be the resultant velocity? Because you want to find velocity of boat with respect to ground. So we know that the relationship between these two motions is something like this: velocity of boat with respect to river plus velocity of river with respect to ground, right? That's the relative motion. Yes, right? Yes. Okay, any issues? Now what is this? What is VBG? VBG is your resultant motion. Yes or no? Right? That's your resultant vector, right? Head of initial vector and tail of initial vector and head of initial vector. So if you see the actual motion, if you see the actual motion of the boat, right? What do you think? How will the boat move, right? What will be the actual motion of boat? The actual motion of boat, right, with respect to someone sitting on the ground is something like this, right? It's suppose we have an observer sitting over here, right? Wait, just right over here. Suppose we have an observer who is sitting over here, right? Just in front of point A. So according to this observer, it will feel that boat is moving in this direction. So instead of going at point B, the boat will reach at point C. Yes or no? Tell me. Yes or no? Agree with this? Everyone agree with this? Tell me. Everyone agree with this? Okay. So are you actually imagining this? Is it clear? Is it clear to everyone? Can you picturize this scenario? Can you just picturize this scenario? There's nothing to explain. You just have to imagine, right? Close your eyes and imagine. Just think about this scenario, right? If you are sitting on a boat and you want to row across this river, okay? So if river is not flowing, okay, then you will reach point B, directly opposite to A, if you're just rowing in this X direction. Yes or no? Right? Yes or no? Okay. But if river is also flowing, right, so it will have two components of motion: x because of this rowing and y because of the flow of river. Okay, right? So this motion will become two dimension, so it will be in this direction. So this is point A, this is point B, this is point C. So the velocity, right, will be in both x-axis and y-axis, and displacement will be AC, right? Displacement will be AC, right? This displacement instead of AB. Yes or no? Tell me. Yes or no? Everyone is getting this? Everyone have this conceptual understanding of vectors? Because if you're having trouble in understanding this diagram, then you have not studied vectors properly. Okay, you have some issues with the concepts of vector. Okay, yes. So it's like if you're running, just imagine if you're running in straight line and someone is pushing from your sideway. Okay, if someone is constantly pushing from your sideway, right? Okay, then obviously you won't run on a straight path, right? That's what will happen. Just imagine, right? So I can say that we have velocity of boat with respect to ground is equal to, right? This is 5 I cap and this is minus 3 j cap, right? So this is your vector. Okay, now magnitude wise, magnitude of vector bg is equal to root of 5 square plus 3 square. Okay, so it's pretty easy. Root of, tell me, 34. Okay, right? Okay, everyone. Okay, let's see another live uh, phenomena. Okay, that we see always. Now, I hope everyone have actually went outside in rainy season. Yes, agree with this. Is there anyone who didn't went out in rainy season or who didn't use umbrella at all? I hope everyone used umbrella. Yes or no? Right? Everyone used umbrella. Okay. Right, everyone? Everyone use umbrella. Very good. Very good. Now, just think about this. Okay. Just think about this. If you are just walking on a road, right? Just suppose you're walking on a road, right? So what is the usual direction of your umbrella? Okay, I'll just draw 3 figures. Okay, the first is, I'll just draw a bit of figure. The first is this is your first A. Okay, this is your diagram B, and this is your diagram C. Okay, so tell me, what is the general direction of your umbrella? A, B, or C? And you are going in this direction. You are going in this direction. Okay, in all the 3 cases, you are going in this direction, right? So A, B, or C, what will be the direction of your umbrella? A, B, or C? Just imagine, how do you keep your umbrella, right, to protect yourself if you're going in this direction? Will it always be A or B or C? Or is there any other factor? Tell me, is there any other factor? Rain is coming from upside only, na, right? Rain will be in this direction only. I'm not considering wind and all those things, right? Rain will be in this direction only. Okay, right? Rain will be in this direction only. Okay. Okay, so most of you are saying B. So those who are saying B have clearly not used umbrella, I guess. Okay, we don't keep umbrella just upside down usually. Okay, we keep in the backward side if you're moving in forward action, right? Mostly. And B is very rare case. Okay, if we want to save ourselves, we usually keep in either A or C depending on the direction of motion, and in real case it also depends on the direction of wind. Okay, so I'm just not considering the direction of wind over here. Now let's break this down. Let's break this down with respect to vectors. So see this. This is your the direction of velocity, sorry, direction of rain with respect to ground. Yes or no? Tell me. Direction of rain with respect to ground. Okay, right? Let's understand this. Okay, very good. This is direction of rain with respect to ground. Now this vector, this vector over here, right, is velocity of man with respect to ground. Yes or no? Tell me. Best, yes or no? Right? Now tell me, what will be the direction of rain with respect to man? Think about this. Just think about this. Velocity of rain with respect to man is equal to what? Velocity of rain with respect to man. Now, Prahlad, you made the same mistake that I was talking about. Okay, you made the same mistake. If you're observing this vectors, right? Most of you might write this velocity of rain with respect to ground plus velocity of man with respect to ground, right? But is this correct? Is this correct? Tell me. Vaishnavi, I just said, what will be velocity of rain with respect to man, right? Now, this is not correct. This is wrong because I told you if you are having this plus sign, then this and this should be same, right? So the actual statement should have been this velocity of rain with respect to ground plus velocity of ground with respect to man. Yes or no? Yes or no? Tell me. This should have been the actual correct statement. This is your correct statement. This is your wrong statement. Okay? Right? So, but you might ask, okay, but ground is not moving with respect to man, right? But again, it's a frame of reference. It's a frame of reference. Okay, if you're sitting on a bench, and then you're observing a person moving in forward direction, then that person is moving in forward direction with respect to you or with respect to ground, right? But suppose you're sitting on someone's shoulder. Suppose you're sitting on someone's shoulder, right? So what do you feel? That ground is moving with respect to you. Yes or no? That's what you will feel, right? Okay, and we know that in vectors velocity or any vector of a with respect to b is equal to minus of b with respect to a, because you just change the direction, nothing else. Yes or no? Tell me, yes or no? Right? So velocity of rain with respect to g is actually your this velocity of, right? Now velocity of ground with respect to man can be written as minus velocity of man with respect to ground. Yes or no? Tell me. Just think about this, right? You don't have to mug up all the formulas. You just have to think about this one. Okay, right? I'll just delete this because you might not be okay. Some people just remember wrong concepts and then they'll say you taught this. Okay, so you just remember this. Okay, obviously it will be correct now because minus of velocity, right, man with respect to ground is just opposite of ground with respect to man, right? That is your concept in vector. Yes or no? Tell me, yes or no? Right? Agree? Everyone is? I'm just writing a statement, Prahlad. I'm just writing a statement, right? So I can just redraw the vector diagram. Let's redraw the vector diagram. So this is your velocity of rain with respect to ground. Now, we had this direction. This is your velocity of man with respect to ground. But I told you to take it opposite. So this is minus velocity of man with respect to ground or velocity of ground with respect to man. Yes, right? Now, this will be the direction of your vector. Right, everyone? This will be the direction of vector. Okay? Right, everyone? Yes? Okay? Got it? Yes or no? Everyone have a clear concept of this? Anyone is having any issue? Tell me. Just try to imagine. I'm giving you 2 minutes. Just try to imagine. Just try to visualize this concept. Just try to visualize this concept. because physics is all about imagination. Okay, if you imagine, if you can imagine, it will be easy. Okay, it will be easy for you to learn physics. Okay, right? That's why conceptually we don't have many topics. Okay, technically if you see, okay, there are 5 or 6 concepts in one chapter, but those concepts are very good. Okay, those concepts are very good, so you have to imagine. Okay, you have to imagine. Motion plane was chapter 4. Okay, Prahlad, motion in plane is chapter 4. Okay, so I guess everyone got this. Now let's see some problem based on this relative motion. Okay, everyone, right? Let's see some problems based on that. Just give me 1 minute. Just give me 1 minute. Okay, sorry, my bad. Yeah. I don't know since when it's not recording. Okay, yeah. So question number 4, everyone. Question number 4. 4, 4. Janvi, not 5, 4. We just explained the concept which will be used in 4. Tell me, what will be the time taken? Just calculate, it's easy. Okay, okay, Janvi, I'm getting the concept. Okay, everyone. Okay, so let's see. Acha, before continuing, I would like to ask this. Shall we take like, if all of you are fine with that, shall we extend this class? Because I really wanted to complete this topic. Okay, because if I won't complete this topic, you will forget. So whatever I have done today will be of no use, because this is from experience. You guys don't revise. You guys just don't see what have been taught. Okay, so if I can extend this class, right? Or I'll just extend this class and I'll give you holiday on Thursday. Would it be fine? Okay, would it be fine? I really want to complete this whole concept, because if you guys won't solve problems, then it will be difficult. Okay, so problem solving is one of the important concepts. Okay, right? So that would be fine. Okay, thank you everyone. Right? Okay, game development class is there. It's there today, kya? Okay, yeah. Okay then, take no issues, right? No issues. So what we will do, we will have a class. Okay, it's fine. We will try to solve some problems. Then we will have next class. Okay, I completely forgot. Yeah, completely forgot about that. Okay, in afternoon, I'll message. Okay, so if possible, we will have a class around 3 p.m. Right? Okay, everyone. 3 p.m. works fine with everyone. Tell me, 3 p.m. works fine. Okay, right? Okay. Thank you. Thank you. Yeah. Okay. We will extend the class on at 3 p.m. Okay. Okay. Yes, 3 p.m. today. Today. right? I really want to complete this concept, okay? Because you guys will forget. If you won't practice problems, you will forget, okay? So one more problem, just let's complete this before wrapping up this problem, okay? 3 to 4 only, Vikas, 1 hour, don't worry, 3 to 4 only, okay? So question number 4 is easy, I guess. So relative motion, since it is opposite direction, so it will be added, right? Velocity of A with respect to B is equal to velocity of A with respect to C. It is opposite direction. So with respect to A, right, B will be faster, okay, right? So the resultant velocity is 90 kilometer per hour, okay, and total distance is 500 meter, which is half, tell me, half kilometer, right? So you can just calculate Navya, because it is moving in opposite direction now, right? Just think about this. Velocity of A with respect to B. Now A is moving in this direction. The velocity is 50 kilometer per hour. So it is 50 I cap. But B is moving in this direction. So this is your minus 40 I cap. Got it? So let's see. This is just see this now, right? Just imagine, right? If you're also running in a forward direction, okay, and your brother or sister is coming from that direction, okay, you both are running in opposite directions, so you will meet faster, you will meet soon, or it will take more time if you both would have moved in same direction, right? That is your imagination, okay? Now if you think about vector, it is velocity of A with respect to ground minus of velocity of B with respect to ground, right? But this is, what is this? This is your 50 I cap minus, and this is a minus of 40 I cap, right? So it will be 90 I cap. Got it? Right, everyone? Got this? Right? Okay. Anyone have any doubt in this? Tell me. Got it? Right? So you can convert? Yes? Okay. Right? So just have to convert this kilometer per hour into meter per second. So it is 90 into 5 by 18. 90 into 5 by 18. Right? Okay. Yes. I wrote VBG because this is negative now. That's what I wrote. That's correct now. Right? See, I have written negative, Prahlad. Right? Negative. That's why I have converted to BG. Okay. Okay. So this is 10 times, this is 2 times, this is 5 times. So we have 25. Our distance is 500. So 500 by 25. Can you calculate? Wait, did I make some mistake? Okay, yeah. Each train, nah, sorry, each train has length. So 1000, sorry, my bad. Yeah, 40. Got it? Very good. Now, fifth equation of motion are not valid for relative motion. True or false? 5 by 18 now, yeah. 5 by 18. Convert kilometer per hour in meter per second. That's why we take. Okay? Because answer is in seconds. Got it? Next, question number fifth and sixth. Sixth is numerical, right? Try to solve question number 6. Fifth one, it should be false. It can be used, right? Relative you can use. Okay. 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 So sixth one is easy, right? Okay. So question number 6. I hope all of you remember the concept. This is yours. This is speed of man, which is 5 km per hour. And this is your, tell me. This is your west. This is your east. If we should swim a river flowing east, okay? Now he is swimming in this direction and river is going in this direction. Got it? So net speed will be 3 km per hour. Yes or no? 3 km per hour. And distance is 3 km. So the answer would be 1 hour. Got it? Okay. Okay, everyone. Thank you. So we will cover all concepts. We'll try to solve more problems at 3 o'clock. Okay, everyone? Okay. I hope all of you understood what is the concept of relative motion. Yes? Okay. We will meet at 3 p.m. Everyone will meet at 3 p.m. Okay. Bye, everyone. 3 p.m. to 4 p.m. Okay. 3 p.m. to 4 p.m. Okay. So last part is just distance by speed, na? Prahlad, last part is distance by speed. Distance is 3 km and speed is also 3 km per hour. Okay. Yes, no, right? See, it is time is equal to distance by speed. Now, relative speed is 3 km per hour, right? Because in this direction it is 5 km per hour, and in this direction it is 2 km per hour, right? Okay, so total. Now, this is the speed of river. Okay, this is the speed of river. Just have to imagine. I'll just use the equation. Don't worry. So velocity of man with respect to ground is equal to velocity of man with respect to ground plus velocity of ground with respect to river. Okay, wait. Sorry, my bad. Velocity of man with respect to ground. Because you have to find the velocity with respect to ground. This is velocity of man with respect to river plus velocity of river with respect to ground. Yes, everyone. Now velocity of man with respect to river is given as 5 km per hour. 5 plus. Now velocity of river with respect to ground is given as minus 2. Opposite direction. Right? See. Opposite direction. So this will be 3 km per hour. Got it, everyone? Yes? Okay. Now we have got this. Okay, everyone. Thank you, everyone. We will see each other at 3 p.m. Okay, bye, everyone.